In this video, I'm going to find the exact value of tangent of pi over 3 plus sine inverse of 5 over 13. By looking at the question, by looking at this plus here and tangent, so we are dealing with sum and difference formula for tangent. In your note sheet, if this is a sum and difference identities or formula, we have tangent of a plus b equal to tangent of a plus tangent of b over 1 minus tangent of a plus b. So why did I pick this? Because of the addition here, and tangent gets a, an angle, or alpha plus beta. So if I call this one alpha, this will be beta. Then I can use this formula. So let's hide this layer. I'm going to write the formula that we are going to use. Let me pick a lighter color. It will be tangent of alpha plus beta equal to tangent alpha plus tangent beta over 1 minus tangent alpha times tangent beta. So we have this inside of our note sheet. Now we're going to call it Claude. So back to the question. Tangent gets, this is alpha and this guy is beta. Sorry, I keep changing the color, but this color is kind of burning my eyes. So we are going to use this formula. So our alpha is pi over 3. Inside of the in note sheet or your unit circle, we know tangent of pi over 3 equal to radical 3. So we also know this one. So actually for tangent of alpha, if alpha is pi over 3, we can just substitute root 3 for now. So let's do it. So we're going to have tangent of alpha plus beta equal to radical 3 plus tangent of beta divided by 1 minus root 3 tangent of beta. So here's a multiplication and this is addition. So if we find tangent of beta and we substitute it here and we do simple, if we simplify this, then we are done. So now our job is to look for tangent of beta. What do we know about beta? We know, we know that sine inverse of 5 over 13, I called it beta. From here, that means sine of beta equal to 5 over 13. So we have value of sine at angle beta is 5 over 13. And 5 over 13 is not something that you have it in your unit circle. So how do we get tangent of beta from sine of beta? We need to draw a circle and use Pythagorean, apply Pythagorean theorem to the triangle. So this is plus, that's minus. So now the question is, where should we draw a triangle? Sine of beta is positive on this one. Sine is positive in quadrant 1 and quadrant 2. And sine has an inverse. This inverse, Sine has the inverse in quadrant 1 and quadrant 4. So therefore, we need to draw a triangle in quadrant 1 because it's positive, also has the inverse on that. So I'm going to randomly make a triangle here. I label this beta, make a 90 degree. We know sine of beta is 5 over 13, which is y over r. That means this is 5, this is 13. We need to solve for x. By applying Pythagorean theorem, we know x squared plus 5 squared equal to 13 squared, x squared plus 25 equal to 169, x squared equal to 169 minus 25 equal to 144. From here, x equal to plus minus radical 144, which equal to plus minus 12. Because we are in quadrant 1, our x is positive, therefore x should be positive 12. So we solve the triangle. When we solve a triangle, so not what we're looking for, we were looking for tangent of beta. Tangent of beta, the form tangent of beta equal to y over x. Therefore is 5 over 12. So 5 over 12, we solve it. Now we have to substitute there. All right, so now we have to do some algebra. I'm going to continue from here. I will go to another layer. So we had this equal to tangent of alpha plus beta. We solve tangent of alpha, which equal to tangent of pi over 3 equal to root 3. We knew this. We solve tangent of beta from sine of beta, which was 5 over 12. So now we're going to substitute tangent of alpha plus beta equal to tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. This equal to radical 3 plus 5 over 12 1 minus radical 3 times 5 over 12. So definitely we cannot just leave it like this. I know we solve it, but algebraically this is not correct. Equal to. So I'm going to simplify the top here. The common denominator will be 12. We're going to have 12 root 3 over 12 plus 5 over 12. This will gives us 12 root 3 plus 5 over 12. Now the denominator, we have 1 minus root 3 times 5 over 12. So here's multiplication. That's a 1. Find the common denominator will be 12 over 12. This will be for the 1 minus 5 root 3 over 12 divided by 12, 12 minus 5 root 3. So now we need to, this 12 and that 12, they cancel. We have 5 plus 12 root 3 divided, I wrote 5 first and then 12 root 3. And then we have 12 minus 5 root 3. So this is not the final answer, but this is much better than this one. But another problem is we have a radical on the denominator. In order to get rid of that radical, because there is a minus here, we have to multiply this by the conjugate. So let's see if I can solve it on this part. So I'm going to multiply top and bottom by the conjugate. Okay, we have 5 plus 12 root 3 divided by 12 minus 5 root 3. I'm going to multiply this by 12 plus 5 root 3. 12 plus 5 root 3. So this is a minus b. You multiply by a plus b. That's a conjugate. The answer will be a squared minus b squared. So a squared is 144 minus b squared 5 root 3 squared. This is 25 times 3, which is 75. It will be equal to 144 minus 75 equal to 69. Now on the top we have 5 plus root 3 times, so we have to distribute 5, so this times that 5. Maybe sometimes we can leave it as is on the top as long as there is no radical in the denominator. But if you want to simplify it, so we can say 5 times 12 is 60 plus 5 times 5 root 3 is 25 root 3. 12 root 3 times 12 is plus 144 root 3. And 12 root 3 times 5 root 3. 12 times 5 is 60. 60 times 3. Then root 3 multiplied by root 3 is 3. So we have 60 times 3 is 180 minus 180. I hope I'm right, but so now we can simplify this 2, and 60 minus 180 is negative 120 plus 25 plus 144 equal to 169. So this will be the final answer. So I know most of you guys don't like this part because it's all algebra. But the good thing is most of the question, homework or exam, it will be similar. If you solve few of this, then you will have more confidence.